I've proven lines parallel today. It's actually very, very simple. It takes what we've known, kind of, if you're looking at this screen right here, here's where we've started. We started being told that lines are parallel, and then we, because of what we learned in this chapter, found out that corresponding angles are congruent, alternate exterior angles are congruent, consecutive interior angles are supplementary, alternate interior angles are congruent. And then obviously we know that two lines, if they're perpendicular to the same line, then those lines are parallel. So the way that we've done this is we started with parallel lines and we got all this. Well, now we're going to flip that. We're literally taking the converse of all these, as you learned earlier on what that means, but it's very, very simple for what we're doing. So let's jump down here to example 1. It says the measure of angle 1 is equal to the measure of angle 2. So if I know that these are equal, all right, because these are corresponding angles, you can see right there I drew the F. That means that R and S are parallel to each other. So we're taking our rules or our theorems, corresponding angles in this one, and we're saying, hey, because those corresponding angles are the same measure or they're congruent, then I have parallel lines. That's how it works. Take a look at example 2. It says find the measure of angle ABC so that M is parallel to N. Well, when you find ABC down here, you see that it's alternate interior angles with BAD. We got those two things right there, that for M and N to be parallel, these have to be congruent, or they have to be equal to each other. So I can take 3x plus 10 and I can set it equal to 6x minus 20 and do the math. You can see the math right here, very simple algebra right there. We get to x equals 10. Now we got to make sure we answer the question. It said find the measure of angle ABC. Well, right here, 10 is not the measure of angle ABC. I'm going to plug 10 in for x. 6 times 10 is 60. 60 minus 20 is 40. That's how we get that. So as you go down here, it's actually very simple, okay? All you're going to do in these is find x so that L and M are parallel, but then you're going to identify the postulate or theorem you used. That's these. That's your corresponding angles, alternate exterior, alternate interior angle. Okay, and I think that's all you're going to see on this. So find x so that these are parallel. We'll set these equal to each other. And find x and say, hey, those are equal because they're alternate exterior angles. Same thing here on number 3. It's kind of a funky looking Z, but you've got this 90-degree angle and 3x plus 15. They're alternate interior. 3x plus 15 equals 90. Solve for x. Jump down here to 6. You got corresponding angles right there. 5x plus 20 and 70. So I'll set them equal to each other and go. On your assignment today from 3-5, you only need to do through numbers 1 through 10. Thank you.